Welcome to our business track of the Data Science Salon YouTube channel. For this session, we have Michelangelo D'Agostino, former VP of Data Science and Engineering at ShopRunner. Data scientists are hard to hire, as you know, but too often companies struggle to find the right talent, only to make avoidable mistakes that cause their best data scientists to leave. From organizational structure and leadership considerations to tooling and infrastructure to avoiding Fomo through continuing education, Michelangelo will share concrete and inexpensive tips to keeping your data scientists engaged, productive, and performing at their best for your business. Enjoy the presentation.
All right, thanks a lot. My slides are up, great. It's good to be here with you all at the Data Science Salon. My name is Michelangelo D'Agostino. I lead the data science and data engineering teams at a Chicago-based company called ShopRunner. I'll tell you a little bit more about what we do throughout the course of this talk. But before I do that, I want to do a quick show of hands. How many of you in the audience currently manage data scientists? Okay, a handful of you. How many of you might want to manage data scientists someday? Okay. And how many of you never want to touch management with a 10-foot pole? So maybe like a third. Some of you who said you are managing don't want to touch management with a 10-foot pole. Perfect. Okay, so hopefully there should be something for all of you throughout the course of this talk. So I should say at the start, this is kind of a different talk than I'm used to giving. I'm used to giving much more technical, code-heavy talks with actual data and graphs and stuff like that. But lately I've been spending a lot more of my time thinking about other kind of more cultural issues, partly because about a month or so ago, I finished this report for O'Reilly with an awesome co-author, Katie Malone, who's also a data scientist in Chicago, where we tackled a lot of the topics around how to build and manage and keep data scientist teams really happy. And so the topic that I landed on for this talk is an issue of retention in data science and what we can do as data science leaders or managers or even team members to keep our teams like really thriving, exciting places where like our best data scientists want to stay for a really long time. And I kind of started thinking about this issue probably about 4 or 5 years ago, actually, when I was managing a fairly large team of about 20 folks at a previous company. And I had what I thought was a pretty decent amount of like success in my career. I had a PhD, I was managing a large team, I had built models that made millions of dollars for companies I had worked for, and I thought everything was great. And every week I would get these like amazing recruiter emails that were like telling me how great I was and could I just come work for these other companies. And I was like, wow, this is like really great. And then one day I was talking to a pretty junior guy on my team, great data scientist, really smart, but someone like pretty new in his career. And the topic of recruiters came up and he was like, oh yeah, I get these recruiter emails like every single week. And like all of a sudden I had this like, oh shit moment. I was like, wow, it's not me. Like there's not anything special about me or where I am in my career. Like every single person on my team is getting these messages from recruiters like constantly. And then there's this like mathematical corollary that comes from that, which is like the minute I messed something up or our company messed something up and like we pissed off someone on the team or they didn't like the work they were doing anymore or they just weren't happy, all they had to do was like tune into that stream of recruiter emails and they were going to leave. And so this was like my anecdote, but there's actually a bunch of data that bears this out. So this comes from Figure 8, the crowdsourcing company. Last year they did a survey asking data scientists how often they get contacted by recruiters. And you can see 30% of people say several times a week, another 20% once a week. And if you want to kind of sum it up into something a little pithier, basically 85%, essentially everybody is getting contacted about job opportunities at least once a month, half of people at least once a week. And it seems like this actually has some real effect. At least some people kind of tune into this endless stream of opportunities. This is from another survey asking how long people stayed at their previous job and plan to stay at their current job. You can see the kind of modal answer is somewhere around like 1 or 2 years, just pretty short, like not a super long tenure. And as any of you who raised your hands earlier and said you're managing knows, like it's super hard to find good people and to hire them. So this is from, I believe, an IBM survey where people said that kind of it takes anywhere from a month to 2 months to fill data jobs. In my own experience, it's actually much longer if you're trying to hire good people. Can be, we've waited 6 months or longer to hire people. So it's clear that the thing you should do when it's really hard to hire people is to keep your best people from leaving. And so that's kind of why I wrote this talk in the first place, to try to convince you that there are some really simple, concrete things that we can do, both as like teammates and as data science managers, to keep our team super engaged and happy and performing well for the business, and not wanting to kind of tune into that siren song of the recruiter. So quickly, I'm just going to give you a little bit more information about my background, and then I want to talk about a handful of these topics. So the first is a little bit about organizational structure of data science teams. The second one is some thoughts around tools and infrastructure. Then I want to talk about Agile. It was interesting, there was a talk earlier on Agile. I think I might have a slightly different philosophical take on that, but I'll talk about that. And then at the end, I think sort of my favorite topic, which is kind of continuing education for data scientists and data science teams. So let me breeze through my background really quick. I'll try to do it in just like 2 photos. So this is me in 2007. So I'm also a physicist by training. I did a PhD in particle physics down the coast at Berkeley, and that's how I got my start in machine learning, doing machine learning for particle physics experiments. And then somewhere along the line, during a postdoc, I answered a random job ad and left to go work doing data science on the Obama re-election campaign in 2012. So doing lots of work around social media analytics, email fundraising, predictive modeling of voter behavior, et cetera. And that sort of started my journey into building and managing data science teams. So since then, I built a data science team at Braintree, which was eventually acquired by PayPal. Ran a team at Civis, which was a spin out from the Obama campaign. And then recently have been at ShopRunner building the data science and data engineering practice. And so if you were at Ali's talk earlier this morning, I can kind of just like breeze through a little bit of the background about what ShopRunner is, but the elevator pitch is sort of like we run an Amazon Prime-like service for the other half of the internet, essentially. So millions of members who get free 2-day shipping and returns and deals across this growing network of retailers. And I'll skip through that a little bit. But fundamentally, we're actually more of a data and technology company. So we have deep integrations with all of our retailers, and we collect really granular behavioral browsing data, product catalog feeds. Ali talked a lot about how we clean up and reconcile that product catalog. And then our team's charter is basically to use all that data to build interesting personalized experiences for our members, but also tools for our retail partners directly. And so we work on a lot of recommendation-related problems, intelligently surfacing retailers and brands, recommending the right product at the right time, applying NLP and computer vision to our product corpus, and all sorts of stuff like that. So just to summarize this quick part about my background, so I don't know if you've seen these farmers insurance commercials where like a cactus falls in a house and this guy comes out and he's like, we know a thing or two because we've seen a thing or two. I think like at this point in my career, like having built teams at various places, I know a few things and have made a lot of mistakes actually, and hopefully you can benefit from some of the mistakes that I've made. All right, so first topic I want to talk a little bit about is how to structure data science teams within organizations and ways for that to go wrong. So I think the high level thing is not controversial, which is that good leaders and the right structures can create happy teams, and when you mess that stuff up, you can drive people away. And I think one thing I emphasize is that data science is fundamentally different as a discipline than engineering. There's obviously a lot of overlap, but it is sort of a distinct practice. Our work is less well-defined, it's more experimental and iterative, and kind of end-to-end in nature. And oftentimes, I've seen companies that try to start data science teams immediately have their data scientists report to like an engineering manager or report to a product manager who doesn't kind of culturally understand what it is that the data scientists are trying to do. And that's a way, I think, to drive talented people away pretty quickly. Data science teams tend to do best when they have a data science leader, someone who actually understands the practice of data science and what makes it similar to and different than engineering. The second thing is that data science is inherently cross-functional, and so you work a lot with business stakeholders, you work with engineers, you work with analysts, and so deciding how to structure the team is a really complex issue. I think a couple of things that I've seen in practice is that data scientists often get lonely when they don't have other data scientists to talk to and bounce ideas off of and stand at a whiteboard with and sort of just go back and forth with. And so sometimes there's a temptation to like, you hire a handful of data scientists and you put each one on a team fully embedded throughout your organization, like this kind of fully dissolved model. And that often goes awry because those data scientists get super lonely. And on the other end of the spectrum, you can sort of have the centralized data science team where it's sort of a little bit too far from the business and they're not in touch with the problems that the business actually needs to solve. And so I think we often recommend, like when teams are starting out, when you're sort of in that like 5, 10, 20, like 25 type scale, like this hybrid model can work really well where you have a centralized team, but you sort of loan out your data scientists and embed them for like almost tours of duty on different product teams or with different business units, but they still have that centralized home base that they spend a lot of their time with so that they can bounce ideas off and feel like they are learning. The second thing, again, this is not super controversial if you are a data scientist, but a lot of companies get wrong, is that they often think their data science team should do all of their BI and reporting, and they hire a bunch of data scientists who are super excited to come in, and then they ask them to just like write a bunch of SQL queries or like design some dashboards. And don't get me wrong, like that work is super important. It's really like sort of foundational. If you can't even report on your data, you shouldn't probably be doing really sophisticated machine learning, but it's not what data scientists sign up for 100% of the time. So we've seen teams be really successful when there are separate standalone analytics teams that actually focus on that, but the data science teams are able to focus more on some of the machine learning and predictive and algorithmic type work. And then the last bit about this is that this is also not controversial, but again, we see people mess this up all the time. Actually train your data science managers and create a technical promotion track. So don't just force people to manage data science teams because you need someone to manage a data science team or because it's the only way for them to climb up the career ladder in your company. It's not going to be good for them if they don't want to manage people. It's not going to be good for the people they manage if their manager doesn't actually want to manage. So make sure that you create a path for people to grow and get promoted by doing technical work, but also by going into management if they truly feel like they want to go into management. Okay, so now a few thoughts about infrastructure and tooling. So I think the first thing is that a lot of times companies hire data scientists without giving them the right tools to actually do their job, or not understanding how data science work is different from engineering and why that calls for a different set of tools. And so I think the fundamental thing here is that data science work is inherently it's experimental and it's super elastic, and that implies a certain set of tools. So maybe you start training a model on your laptop, but then you need a server with more memory, or you want to parallelize a grid search, or you need to run something on a cluster, and for a while you need to run it on 100 nodes, and then you need to scale it down. And if you don't give your data scientists the ability to work with this scalable infrastructure, they're going to get super frustrated. Like if they have to put in a ticket to an IT department to get a server or to like have them install a Python package, they're going to get frustrated really quickly and they're probably going to quit. So strategies we've seen work in the past have been either like setting up dedicated cloud provider accounts that your data science team can sort of use as a playground or a sandbox without messing up all your production infrastructure. That can work really well if your data scientists feel comfortable going in and booting up instances and managing their stuff, but they're not going to mess up a lot of the other infrastructure. Or moving to sort of the new generation of kind of collaborative cloud-based data science platforms is also super successful. There are a whole bunch of them out there, depending on if you're based around Python or R, or if your Spark is in your stack. But all of these things like inherently give data scientists what they want in order to work. Things that can scale up and down. They're not blocked by DevOps or engineering in order to actually get their work done. That's super, super important. And then again, I think this is important, but not necessarily always in your control. So what we see is that data scientists, because the average tenure in jobs is only a couple years, they want to learn skills that they can take from one job to another. And so a lot of the cutting edge is happening in the open source stack, and people want to learn those things so they can take them from job to job. And so if you're not working in those stacks, that kind of communicates something to your potential candidates and to your current employees, and it might be communicating something that is not going to make them excited to stick around. Okay, so now I want to talk a little bit about how you actually run your team, and ask the question I like to phrase is like, should you Agile or not Agile on your data science team? And for those of you who aren't familiar with Agile, I'll go back to this Agile manifesto that kind of kicked it all off, written by these kind of engineering process thinkers I forget when it was, not that long ago. But they staked out kind of this like philosophical position that said, basically, we're trying to figure out better ways to write software. And so we value certain things over others. We value individuals and interactions over processes and tools. We value working software over documentation and requirements. We value customer collaboration more than contract negotiation, and then responding to change over following a plan. So they're trying to say these things on the left are more important than the things on the right. And then they made a few other recommendations. So deliver working software really frequently, from a couple of weeks to every couple months. Business people and developers have to work together really closely. And then simplicity, so maximize the amount of work not done. So this philosophy sort of started out the Agile movement. And kind of like most like revolutions, it's become so accepted that it's not really controversial anymore. Like there aren't that many places that say like, oh, we're proud of our waterfall software design principle. Like everyone kind of does Agile. But what's happened is that like a whole industry has grown up around Agile with like certifications and formalized roles and formalized processes and like terms and a set of like meetings and ceremonies that you have to have. And in some ways, like you can point everything and estimate and look at graphs for how your team is working and measure every aspect of how your team is working. And I think for a lot of data scientists who have this process sort of imposed on them, it feels a little bit like this cartoon. And there was this article from Stitch Fix from Eric Colson, I don't know, maybe like 4 or 5 months ago called, I think it was Beware the Data Science Pin Factory. And the whole point of that article, and I think what I'm trying to get at here, is that a lot of data scientists got into data science because they were super excited about like poring over a data set, trying to find something new that they hadn't thought about before, learning something new that they didn't set out to find in the first place. And that it's not this like assembly line where you can write down on your Jira board, like first do step A, then do step B, then do step C, and just like specify out all their criteria. There's this kind of creative exploratory process that's involved that in some of the Agile formality can make data science teams really unhappy. And so I tried to get some evidence for this in the most rigorous way that I could. There was the thing about surveys this morning where people talked about how important it is to properly design survey questions. So I designed a super biased survey. I asked people on Twitter how they felt about Agile. So it's great for data science teams was 3%. I hate everything about it was 21%. I hate it, but I'm not allowed to say that I hate it was 8%. And then by far, the majority winner here is that what's actually important is the Agile mindset and philosophy more than like implementing a rigorous set of like tools or meetings or processes. And so that's actually what how we practice Agile on our teams and like what I strongly recommend for teams to go back to some of the Agile philosophy that we talked about a second ago. So responding to change over following a plan. That's actually perfectly describes ideally how data scientists work, right? Like it's iterative. You start working on a model, you find out the garbage is data, or the data is garbage. You go back to the data. You build a model again. The performance is good, but you can tweak it a little bit more. Like you're constantly responding to change rather than this like linear process. And that you need to be able to go where the data leads you. And that actually fits in really nicely with this philosophical point. Deliver working software frequently. Again, that's a thing we see data science teams fail at very often. Like you'll sort of go away into your cave for 6 months and work on your model, and then you'll come back. And meanwhile, the whole business is like, hey, what has the data science team been doing? They haven't actually like been showing anything. And so we find that like you constantly actually have to deliver small little pieces of working software and demonstrate it to your stakeholders. So build internal visualizations of the models, let people play around with different parameters, like show Jupyter notebooks to your stakeholders as you're progressing through your workflow. And that helps to build trust and get buy-in for the work that you're doing and help get feedback so that you can change things earlier rather than later 6 months down the road. And then business people and developers must work together daily throughout a project. Again, that really describes data science when it's done well. Like you have to work really closely with the business stakeholders, the analytics folks, the product managers to understand both like how the underlying data is being generated in the first place and how the results of your model are going to be used. So if your data science team is walled off, that's not going to work super well. So, and again, this is exactly what the Agile folks were talking about in the first place. And then again, simplicity is really important. And so I think this is often again, a message that data science teams sometimes forget. So before you go off for the 6 months and build into your cave and build a deep learning model, like build a simple logistic regression as a baseline. And actually, as I said earlier, don't ever go off into your cave for 6 months, because that's just sort of a recipe for failing. Okay, so last thing I want to talk about, which is I think probably my favorite topic, is continuing education for data scientists and data science teams. And I think the core psychological insight here, I think, is that data scientists suffer or can really suffer from Fomo. If you don't know what Fomo is, it's this like social media anxiety feeling where like, oh my God, somewhere in someone's Instagram feed, someone's doing something like much cooler than I am, or like they're having a way better time than I am. And so like in data science, that often takes the form of like, my company isn't doing anything cool with machine learning. Like we just have like a tiny MySQL database, and I hear everyone else is using like Spark or Presto, or like we're not using any cool deep learning frameworks, or we're not doing reinforcement learning, or like X, Y, or Z, whatever the next cool thing is. People feel like they're not doing something cool at their current job, but it really masks this feeling that data science changes super quickly, and if you're not keeping up with new things, you're really going to quickly be left behind and sort of become irrelevant. And that's sort of like what is at the root of this feeling of FOMO. And it bears out in surveys when people are asked why, what would motivate them to quit their current job. Yes, money is up there. Money is always super important. But generally, I think data scientists, more than other folks, value growth and learning opportunities and challenging work as important, because they know they need to constantly be honing their skills. And so if you're not giving people the opportunity to do that at work, that's going to be a problem. So how do you deal with this? The first thing is that, okay, maybe your company isn't actually doing tons and tons of cool work. Not everything companies do is cool. So the first thing you need to do is make sure that you are hiring data scientists who don't just chase after the shiny new things. They actually care about having a measurable impact on your business. But assuming that you've done that, even those kinds of data scientists still want opportunities for learning. And so there are lots of things that we found to be pretty successful and that are essentially pretty cheap for keeping people happy and feeling like they're learning. So the first thing is to institute a journal club. It can be super informal. We usually do it over lunch. Folks read a journal article in theory. Most of the time, a lot of people don't actually read the article, or a blog post, and get together and just discuss it. Often the person that chose the article will give a short presentation about it, but they don't have to. We open it up to other engineers or analytics folks in the company. That's also a really good way to do cross-pollination about what data science is throughout your company, kind of like evangelization. And if you're wondering about where to get ideas for papers, there's a blog called The Morning Paper, which is really great, that has a daily write-up of an interesting computer science or machine learning paper. And then actually, if you go, this is both in the report, which I'll link to later, but also at this link. I subscribe to way too many data science newsletters and link aggregators, and that's another really great way to get ideas for things that you can talk about in your journal club. And kind of you as a data science leader or manager or teammate, like set the example and like go out and be curious and like read about a bunch of this stuff and send it to your team and kind of get that conversation going. Another thing that we've done occasionally is to have kind of like a movie night or like a movie afternoon. A lot of people have conference videos. We're videoing this, right? And they've got this long list of videos that they want to watch, but they just never have time. Like sometimes if we haven't actually picked a journal club article, we'll sit in a room and just watch a conference talk video together and then discuss it. That's another super low cost way to get your team learning about new stuff. Then another favorite one is to give people some amount of dedicated unstructured hack time. And I've tried lots of iterations of this at various companies in the past. Doing a hack day every other week or half a day every so often. And the idea is that you want to give people the ability to explore a new software package or language or a new technique or do something with your company's data that they just haven't had time to do. And I think what we've landed on eventually that's worked the best is to let people take dedicated individual hack weeks. So a day or a half day here and there is not really enough time to get like a meaningful amount of work done, but a week really is. Like you can get a pretty decently sized project done in a week. And you can adjust the cadence. We do it quarterly. You could do it once a year. You could do it twice a year, whatever works with you. But schedule it far enough in advance and tell people to treat it like vacation so they actually can clear out time from meetings and on projects and stuff like that, just like they could for a vacation. And make sure they have done some light amount of planning ahead of time. So they have a project idea. They have a buddy that they're going to check in with really quickly throughout the course of the hack week to make sure they're actually doing something. And I think the most important thing is make sure they do a presentation at the end of their hack week back to the entire team. So that both keeps them accountable because they're going to show up. If they've messed around for a week, they're going to show up and not have anything to show. So there's like some social pressure. But then also the rest of your team gets an opportunity to learn from what that person explored. And I think the coolest thing about hack weeks is that really, really frequently at both companies that I've been at where we've done this, things the team has done end up making their way into our tool set or our production workflows, because your team, like, they generally aren't going to pick something totally random. Like, they have lots of ideas for cool things they can do with your data that might just be outside the scope of what people are asking for. And if you give them a week, they're probably going to pick something that is actually kind of relevant to their day-to-day job. And then maybe 2 months down the road, that seed that they started in a hack week is actually going to become really important. And another trick is to write those things down so that when your boss complains that you're letting your team do hack weeks, you can say like, oh, actually, these 4 or 5 things that came out of hack weeks are now like important parts of our infrastructure or our tech stack. So finally, have a conference policy. So you're all at a conference, that's really great. But like, do you do that for your teams? So the policy that we have that we recommend is to encourage your team to be submitting abstracts to conferences and get your company to pay if their talk actually gets accepted. So it's both great publicity for your company and for that individual person. If it's in your budget, we try to fund just 1 conference a year for learning. If it's not in your budget, tons of these conferences have free videos online, so use that journal club as kind of an opportunity to watch some of those conference videos that maybe folks couldn't go to. Another side benefit of conference attendance, actually, I'm really feeling this way at this retail-specific conference, is that when you're really frustrated with work and you're like, oh man, I hate all this stuff about my company, you go to conferences and you talk to other people and you realize like, oh, it's actually not my company. Like, these are just general problems that data scientists have. Or like, actually, this is just a common problem in retail, and it's like, it's not me, it's everybody. And so that also kind of helps people to feel slightly better. Cool, so hopefully that was just kind of a quick tour through some of these ideas that you can use to try to keep your data science teams happy and productive and not really quitting. So I stole this from some children's book I found online, because I think there's, in like popular culture, there's often this like idea that like data scientists were these like magical unicorns and we're super powerful. But actually, I think data scientists are like a little bit more like fragile and vulnerable and constantly feeling like maybe they're going to be left behind and they need to kind of keep up their skills. And you, as a data science manager, it's sort of your job to help your data science dragon grow, I guess. I'm mixing my metaphors. Cool. And lastly, I'll just flash this up again. You can grab from this link a PDF of the full report. It has a lot more about hiring and recruiting and career ladders and some other topics just aside from your retention. And that's it. Probably don't have any time for questions, but I don't know. 1 minute. All right, cool.
Thanks, Michelangelo. There was a whole question about what do you refer to as FOMO, but that got answered online, so that was great. I really appreciate the comment about data scientists get lonely when they don't hang out with other data scientists. So question, how do you know how to handle the depth? Data scientists know one topic, such as anomaly detection or recommenders, very well versus breadth. The data scientist should have a broad knowledge of most algorithms in a team.
Yeah, that's a good question. So breadth versus depth. So in the report, there's a whole chapter about career ladders. And there are different philosophies on it, but the one I ripped off from another O'Reilly report called Analyzing the Analyzers from maybe 5 or 6 years ago. And I think they ripped this off from like the HR literature, but it's about the concept of like of a T-shaped career profile where you want to be broad across a basic set of things, which is like the top of the T, and then deep in a certain set of things that you might be interested in. So we have like a set of things, 3 things that we think our data scientists in our area should be should have basics in. So I think they're kind of ML and stats, software engineering, and data systems and databases. And so we have like a written set of things that you should cover the basics across those 3 areas. And then as you become more senior, you tend to want to specialize in one of those areas where you will go deeper. So maybe you become an expert in writing software packages and CI/CD and Docker and the engineering part, or maybe you want to go really deep in recommenders and machine learning and you go deep in that part. But everyone has to have like a common basis so they can talk to everybody else.
Great. So like a T or like a pi even. And actually, do we have one more? Okay, one more question because this did get an emoji of some kind, although I can't tell what it is.
Hopefully it's not the pile of poop emoji.
I think it's a surfer or something. What advice do you have for smaller organizations with only 1 to 2 data scientists in terms of explaining complex topics with no binary outcomes to executives who don't get it? Example, the way engineers used to be confused with IT people. You work with computers, fix the printer.
Yeah, I think the couple best suggestions I have for that are some of the things I mentioned. So like journal clubs and Agile sprint demo type things. Like you can't just do it in like 1 or 2 conversations. It has to be like over many months, many small conversations to like bring people along. So depending on like how, folks aren't that senior, and they are interested in data science, they can come to journal clubs to learn more about what data science is. But otherwise, try to get stakeholders to come see micro demos of the things that you're working on. And that way they can see you tried to build a model, but the data is garbage, and then they'll understand why it's important to have quality data. But I don't think there's generally one breakthrough thing that helps to bring people along, I guess. It's a long process.
Actually, maybe we do have a little more time. So one more question. Do you have any, this is from the other Luke, do you have any thoughts on data scientists as consultants versus in-house data scientists, since you distinguish between BI data scientists and data science, meaning companies shouldn't confuse the two? I've struggled to have as clear a value prop for data scientists as consultants versus data analyst consultants.
So the question is, the difference between a data, oh yeah, go ahead.
Do you feel like data scientists as third-party consultants coming into a company are as effective as in-house data scientists compared to just the data analytics or data visualization consultants?
So the question is about third-party data science consultants. That's a whole topic, I feel like, in and of itself. I feel like they can be very effective if you maybe you have a very discrete project that you need to get done, and your in-house teams don't have time to work on that, and you can kind of give them a little bit of guidance about the data and work with them to do it. I think they can be effective, but obviously the difference is that they just don't have the deep familiarity with your data and your systems that in-house people do. And so if your data is super messy and nuanced, and you have developed years of expertise in understanding it, a lot of times that can be hard for a consultant to reproduce, I think. Or they're just going to need to spend all their time with your in-house team to transfer that knowledge, I guess. I have been a consultant in the past, so I can't talk too poorly about consultants. But
okay, great. Thanks a lot.
Thanks.
That was a presentation by Michelangelo D'Agostino, the former VP of Data Science at ShopRunner. He shared great tips for keeping your organization's data scientists engaged, productive, and performing their best. If you really enjoyed that session, please make sure to subscribe to our channel below. Thank you.